Everyone, welcome back to the workshop, and today we are taking a look at the Omtech Maker 25. This is a 50-watt CO2 laser. It is Rita controller based and a little more of kind of your mid-grade, a bit industrial size, but not so massive that it is on its own cart and takes up a ton of space in your workshop. So I'm going to take a look at this one and go over some of the features with it for you. We'll do a few tests and try to give you an idea if this might work well for you in your workshop. So if that's something you want to learn more about, stay tuned. I'm going to jump right into it. So some of you who have been following my channel for a while might ask, hey, isn't this similar to the one you just got rid of? And yes, I have had a similar laser to this. My first laser, in fact, was a CO2 laser that was a 60 watt, just a little bit bigger than this. I got it a little over 9 years ago, and it's been a trooper, but over time, I just used it less and less. It needed some maintenance on it, and had a friend who was willing to kind of do a little bit of elbow grease, bring that thing back into better operating function. And so I said, hey, why don't you play with it, see what you can do with it? And it gave me some room to do some shuffling in the shop. I have had a number of things come and go out of here, and needed to kind of work on my layout. So it was nice to have that out of the way, but I did miss having the Ruida-based controller, the little deeper cabinet. So Omtech reached out to me and said, hey, would you like to take a look at this and maybe share it with your viewers? And I said, sure, why not? Let's bring another one back into the shop. The nice thing is this is just a touch smaller, so it's not going to take up as much space, but it is still going to give me the ability to show you how these type of lasers work, and maybe help you do some troubleshooting, or just give you some ideas on how to better use yours as well. So let's first talk about the delivery. This, if you're used to your typical UPS, FedEx, postal service here in the US, this is going to come a little bit different. So these come crated like a palletized crate, and they're going to come on a freight truck. So the delivery time might take a little bit longer. I think this one was just a little over a week. It was probably closer to about 10 days, and it's going to make your way to your place on a freight truck. So as it gets closer to when they're going to deliver it, you're going to have a dispatch call you and say, hey, we have a piece of equipment coming for you. We will have a lift gate. When can we come and drop it off? They're going to give you kind of a time window, and they're probably going to remind you they're only going to drop it off at the curb, maybe at the end of your driveway, and that they don't want their drivers to be dropping it into your shop or whatnot. Got a little bit of a unique situation here in that my shop and driveway are not off the front, off the street. We have kind of alleyways that come back to the parking in our neighborhood. And even though the driver said, hey, you know what, I can back it up there, we can get it right into your shop, I said, you know, it's just going to be easier let's put it on my trailer. He was very kind. He was able to get it up on my trailer using their pallet jack. Didn't have a lot of problem doing that. Now, push come to shove, this unit isn't as big as some. I think the shipping weight was about 265 pounds. He and I probably could have, lifted it on there if we needed to, but he got it up on my trailer. I strapped it down, drove it around the block, and then I had to get it off the trailer and into the shop myself. So probably should have had some help with this, but it was the middle of the day. Wife was at work, friends were at work, so I backed it up to the shop, dropped the gate down, and was able to kind of shimmy it down using a bit of a hand truck, and then it's just a kind of a steel ramp. Was able to ease it into the shop without any kind of aggressive or sharp movements that might cause some damage. Got it pulled into the shop, popped the top just to make sure everything was good, and then had to go back to work. Then we had to uncrate it, and just a little tip, if you do get one of these, I started popping all of the staples holding the crate together. Well, if you go around the bottom edge, there are some bolts that you can unscrew and then slide the whole top of the crate off instead of tearing it apart on the laser. It is well packed. It's got a lot of foam around it and inside it. And so everything came fine. There was no damage. Both Omtech and the shipper did a great job on that. It's only about 2 feet tall, to where it's got rubber feet in the base. There isn't necessarily a mobile cabinet that this sits on. And being 2 feet tall, some of your typical workbenches may have been a little tall for it. So I did go ahead and build my own base out of this. My base is about 45 inches wide, about 30 inches deep, and about 23 inches tall, plus about 3-inch casters on the bottom. This is kind of the perfect height for me because one of the issues I had with my old laser is the working height. It came on a cart, but the top of the laser was maybe at 36 inches, 40 tops, and I was always bending over, and being 6'5", that after a while, it's a bit of a strain on the back. So it was nice to kind of custom build this to my height. But it's just something to keep in mind that with this specific laser, it only sits about 25 inches off of whatever you're setting it on. So you're going to either need to account for that in some shelving, some cabinetry, or build your own base like this. Now, this being a liquid cooled CO2 laser, we do need to account for adding that cooling. So this unit doesn't come with an integrated chiller. You can opt to purchase a chiller. I'm using my older one. It is a CW5000, which is very similar to the CW5200 that they recommend for this one. And that is what I strongly recommend you get for this laser. It will keep things actively cooled. It can lock it in at a temperature with very little deviation. And it also creates a kind of a sealed environment that is gonna really help prevent from any contaminants. Your other option of what they send with is they give you a water pump and some hoses, and you go and get yourself like a 5-gallon pail, fill it up with distilled water, and then that will work to chill it down to a point. That water is going to heat up over the use of your jobs and such, and if it gets too warm, that's going to start degrading the power of the tube, and it's going to cause a little lowered lifespan. So strongly recommend the chiller. I went ahead, I've built the cabinet area for that with some air movement around it, and can run the lines off the back. You just want to check on the back. They have an inlet and an outlet on both the laser and then also my chiller. Just get those lined up correctly. You know, your outlet on your chiller goes to the inlet on the laser and vice versa. We also needed to hook up the air exhaust on this. This does have about 150-ish millimeter fan on the back and about a 6-inch port on the back. They do include some flexible hosing. So if you're just getting started, you can maybe run that out underneath your garage door or out a window, but you are going to want to figure out how you're going to vent this. And you need to start filling up that laser tube. So take that back panel off of your laser and do a quick inspection, make sure all the hoses look good, and then turn on your pump or turn on your chiller. That'll start moving water through. You do want to let this run for a bit. You want to let it work out all the air bubbles. If you do see some that are stuck, you don't want to leave those in there. Those can become hot spots and cause damage to the tube. So a couple of quick tips on doing that is you can grab maybe the inlet or outlet line of the water coming in or out of the laser and just kind of squeeze them just briefly. That'll kind of pulse the water and kind of help break that surface tension. Hopefully work those air bubbles free. Don't hold it for a long time, but just kind of squeeze it real quick. And then, like I say, it'll just add a little bit of a pulsing to that water. The other thing is if you have some really stubborn ones, maybe get some help. Just lift up one side of the laser, get that tube at an angle to where the air is going to go with the flow up and out of the tube. You just need to make sure that all that air does get out of the tube. All right, let's talk a little bit about connectivity to this laser. It does have a Ruida control panel up here. We can control this completely standalone. You would just need to transfer your files into it. They do over here have a couple of USB ports. The top one is for using a flash drive, a little USB flash drive. As long as you have your files prepared on there, the controller can read them. They also have a USB port that can be plugged into your computer, and that way you can directly control the laser. Now this laser does support Lightburn, which is my preferred software of choice. If you don't have the money for that and want to kind of just step up to it over time, you can pass on that. And they do, you can work with RDWorks. It's kind of the generic Ruida control software, similar to Lightburn. Not quite as well featured, but when I had my laser 9 years ago, I ran that for a good year and a half before making the plunge on Lightburn. So you can definitely operate that way. Or if you're using CorelDRAW or AutoCAD, they do have print drivers that you can run from there. My strong recommendation is to use Lightburn. Then you can run it right off here. Now there is an option. They do have an Ethernet port. You can get this set up on your network. I would recommend going into your router, making sure it has a dedicated IP that doesn't change. Then the other things on this side panel, we do have our main power switch as well as a laser power switch. So you can power on the chassis without powering up the power supply to the laser, which is a nice safety feature. Inside this panel, we do have kind of the guts of this. You'll see that there is actually a 60-watt power supply in here. So that's one thing to keep in mind with this laser tube. It is a 50-watt tube. And in the manual, they do recommend not going over 70% power. So it's probably a combination of the 60-watt power supply as well as trying to keep the milliamp rating down on this. I wasn't able to find a max rating on this tube for the milliamps, but they are recommending you stay under 70%, which puts it in that around 18 to maybe 20 milliamps, which is pretty typical for a 50-watt CO2 tube. It is rated to have about 1,000 to 2,000 hour lifespan, and a lot of that is going to be varying on your operating temperatures of your water, the environment, your power levels that you use it at. So you can expect to get between 1,000 to 2,000. But if you start running at those higher power levels, it's going to go probably below that 1,000 hour rating. All right, so I brought you in closer so we can take a look at the features of the laser. Now, they do include kind of a set of keys. So you've got a couple keys that are going to open up these various panels on the front. You have this triangle key that's going to open up more of the side, the rear, and this front bottom panel. Those are great for accessing things for maintenance. These are more for just operational loading material and your pass-through. They do include a little bit of a cheat sheet on here for acrylic, and so they're showing you kind of the effects of 25 to 95% at 300 millimeters a second. When they're not recommending going above 70%, I'm not sure why they included the 95%, but it's there. Like I say, take care of your laser, keep it under 70% power on here, and you're probably going to be okay. They do also have this block right here, which is going to be your focus block. So this is a preset distance that you basically raise the bed up until this touches the bottom of the air assist cone, and that sets your focal length to the surface of your material. Up top, we have our controller over here. This allows us to do all the functions of the laser standalone. And of course, our e-stop button. This is something that some people forget. If that's pushed in, your laser is not going to fire. You need to twist, pop that out. But it's great to have that on there in case you do have problems. You can hit that. It's going to kill power, kill motion. I'll let you address the situation. Let's power on the laser. Now this does have inductive limit switches, so it's going to home off those. It's going to sense the metal on the gantry and then on the head. And then it's going back to my previous origin point. These inductive limit switches do work pretty well. Over time, they can fail. They're an easily replaced part, so something to keep in mind. It does have some pretty decent linear rails. They are an item that you're going to need to kind of keep maintenance on. You're going to want to clean them up and then re-lubricate them from time to time. But one thing I'm noticing about this one is this head is very solid. There's no wiggle, and so that is going to be very important for getting very precise, clean cuts and such. A control panel, of course, can move the head around, which is really nice. It's nice to be able to control things from the laser. We can set a point and actually hit our origin point. So like I said, if you have files on your controller, you'd be able to run this without being connected to the computer. Now we do have our air assist line coming out here. If you do need to do maintenance, because this head can come off, you just need to push down this little blue cap here. That will release this air hose, and then you would just push it back in when ready to reassemble. And then you can probably see there is maybe, if I lower this down a little bit, there is a little red dot there. Now that's not coming through from the tube. It's just a little emitter on the back side here, and that is kind of set to line up to where it's going to hit the laser spot when it's in focus. So it's great for framing, positioning, but it's not there to help you do the laser alignment. You do have access to your various screws for making those adjustments to set the angle of the mirrors. That's something that if you're new to CO2 lasers, you do need to do. On this one, you would put a little bit of tape over the whole area here or on here, as well as mirror number 1. They do have a pulse function on the laser that will briefly fire the laser, put a spot, and the whole goal is to get a consistent line both front and far and as close to the center as possible in both movements. So you want to start and hit the center of your mirror there, get that to hit the center here consistently, front and back, and then move on to mirror number 3. That's very important to make sure that your beam is hitting the same spot, and then it's going to hit the center of the lens as it goes through. These are belt driven, and they do have some pretty stout belts on here. It's great to see that. They do have some adjustments here for you to tighten the blocks and such. Everything on here seems fairly snug. This is a manual focus. So we have our focus block here. Let me bring you in a little bit closer. So if we had material here, we'll just pretend that we're focusing on the honeycomb here. You see we have a gap here. So what we would do, I'll bring you back out to show you this, but up in this corner we have this knob, and as you turn the knob, it raises up the bed. You're basically just getting it to where this just touches underneath there, and then that focuses on the surface. I'd love to see if it was motorized, or if they just had, like a hex adapter in here that I could use, maybe a power drill or something. This might be a job for like a little 3D printed adapter that I can hook it up to a drill. For minor adjustments of focus here, it's not going to be bad, but one of the nice features of this laser is we do have a lot of depth here. So we can bring this down quite a ways, and it'll drop down. I think if you remove the honeycomb and just go with the slats, you can get up to about 11 inches from here to that. So you'd have about 10.5 inches of focal distance where you could drop an item in and still be in focus. So that's a great thing if you're doing like pre-made boxes, or you need to work with a rotary and it's on a bigger item. You've got the depth to do that, and that's not something you're going to see with a lot of the benchtop units. So does include both a honeycomb and a slat bed. So the honeycomb's great for smaller items. They're not going to fall through, but if you want less flashback on bigger items, the slats are going to work really nice. I like that they have both. The one thing I wish was included is my old laser. It actually screwed in and locked this into a consistent spot. That makes it much easier for setting up fixtures and jigs. A minor annoyance, we could probably fix that. We could probably add our own holes, some machine screws, maybe add some blocks on the bottom of this metal. Not the end of the world, just a little creature comfort I would love to have seen. Now this laser does have integrated air assist, so we've got air coming through here. It's not something you can turn on and off, but if I get this down far enough, you will be able to see that we have an air pump down here, and that's what's feeding this air assist on here. It is constantly on when you turn the laser on. You can't adjust the flow, you can't turn it off. So that might be something we want to look at, maybe swapping that out for shop air. And it does look like we do have connectors in here where we could pop off that pump, maybe even disconnect it from power, and then run it off shop air. Even better is I'll have to look at the controller, see if maybe there's an M8 or M7 port that's available to set up a relay. And then we could turn it on and off in Lightburn as well. You'll also see we have our big fan on the back there. That's going to exhaust all the smoke out. It is underneath the bed, so it should be pulling air down instead of letting it rise up. And then pushing it out. Like I say, I like having an inline fan pulling air out. So in the long run, again, if I get my 6-inch setup going, I may see if I can even just remove that fan. It'll be just one less thing. Anytime you're pushing air, it's going to find any gaps or crevices to sneak out of. If you're pulling it, it creates a vacuum, much less likely you're going to have smoke inside. And then we also see back here, we have a water flow sensor. That's this blue tubing, that's our water coming in and out of the system. That's just to make sure that the laser kind of protects itself. If it doesn't sense water movement, it's not going to let you fire the laser. Now we do have an LED light bar along the gantry here. That works okay. You can kind of see though, the acrylic is very dark. It's very smoked. And that is great for blocking the laser light and such, but makes it a little hard to see in here. I may down the road see if I can add some additional lighting in here. I'll probably have to look and see if I can find some 24 volt LEDs, as I think the control or the power supply in there only has 24 volt and maybe some 5 volt power. But I would like to see just a little more light in here, but we'll be able to work without that. All right, so we've ran a number of tests through the laser. Let's take a look at the results. Start out with some 3mm Baltic birch plywood, and this is a material I use a lot in the shop for a variety of things. It's a little more dense, a little more tougher to cut through than your typical craft plywood. So if you're trying to compare this with your material, take that into consideration. But had some pretty good results here. We ended up blasting through it at 33 millimeters a second, all the way up at 60, 65, and 70% power there. So getting clean cuts. And even on the backside, you can see the ones above kind of wanted to poke through, but I don't like to push them through if they're not really dropping out. Then wanted to step it up to 1/4-inch Baltic birch. Again, this is like a 5-ply and a harder material, typical craft plywood. And I dropped it down from 15 to 25 in the speed. And then of course, just going from 50 to 70% power. Almost wanted to get through on the back there. I don't know if you can see that, but on the bottom here, they're just trying to poke through. Now I maybe could have adjusted the focus down just a little bit, but we went ahead and slowed things down a bit. Went from 8 to 15 millimeters a second, and then we were getting some decent cuts. And they were dropping out, so you can see on the backside they're fairly clear. Again, some of these up here probably could push out, but I try to leave it to where they drop out. They sell this Pure Bond plywood at Home Depot, and it has kind of an MDF core or a poplar core actually, and a thin veneer. This happens to be birch, and so I ran that cut test on there. Now this is closer to 1/4-inch material, And this was getting through at 19 millimeters a second at 65 and 70% power. So I think this is safe to cut at 17 to 18 millimeters a second for this material. So with that, went ahead and did more of an engrave test on here. And you can see the gradient there, definitely getting dark at the bottom there. But this was ran from 200 to 600 millimeters a second, and I went from 10 to 70% power. So I took those numbers and went ahead and did the first little example project here using my logo. Did an engrave and then a cut. This is about a little 3.5 to 4 inches. And we ran this engrave at 450 and 50% power. And then the cut, we of course went at 17 millimeters a second. Did a great job cutting and engraving. And really, I think this one took only about 6 minutes to complete the engrave and the cut. So, you know, having those higher speeds for the engraving and getting the color is working out pretty nice. So wanting to go ahead and use those settings on a similar wood, I have some cedar here, and I had already used this for another keychain, but went ahead and used the Omtech logo and cut it out. This is a little over 1/4 inch, so I kind of guessed I used those same, that 17 millimeters a second and 65% power. I did have to run it a second time, so I think I would back it off to about 15 millimeters a second. But the engrave is really nice. It's very dark. I did have to do a little bit of sanding on all these, and that's just some of that little bit of vaporization burn being on the surface. A little bit of like 300 grit sandpaper in the rotary. That is one area where I would love to see maybe upgrading this to shop air, being able to adjust the flow as well as maybe turn it on and off, which would help reduce that a little bit and possibly help improve our cuts. So another thing I want to do is try a photo engrave. And so I took some real thin birch plywood. We're not cutting through this, and took one of my selfies and did an engraving on here. I did just a little bit of photo manipulation in Lightburn, ran this with the Jarvis dithering mode, and ran it at 600 millimeters a second, 0.1 line interval, and ran that at up to 65% power. So it's got the range from 10 to 65% power. And it did pretty well. This took about 11 minutes. This is roughly about 6 inches in width and height. So pretty good size engraving there, and not too bad of timing there. Face is a little bit dark. I could probably take a little more time on adjusting the settings in here. It's not the best photo per se, because it is so light. It's hard to get some definition in there. But overall, the quality is pretty good, other than, you know, a little bit too dark there. And the speed was really nice for a 6x6 engraving. Pretty happy with that. Of course, one of the reasons you would get a CO2 laser is to work with acrylic, and especially clear acrylic. So I kind of just took a stab at that. This is about 3 millimeter, 1/8 inch, maybe just a little bit under that in thickness. And we ended up getting clean dropouts all the way up 70% power at 23 millimeters a second, but definitely getting some clean ones at 21. It was all but the bottom one there. And a lot of these, you can feel it kind of coming through on this side. Could play around with depth of cut. Also, you know, your air here again, this would be nice to be able to adjust your air a little bit, because sometimes too much or too little can have a big effect on acrylic. But then we went ahead and did an engraving. It did a little bit of skewing at the 600 millimeters a second. I'm just going to chalk that up to this one instance. This is the only time I've seen this not nail the engraves right. So not 100% sure what happened there. I wasn't 100% paying attention. It could have been a little bit of shifting in there, but the quality of the engravings there, and I feel like they're all fairly similar. So definitely wanting to have the speed up there, but probably limiting it to 500 millimeters a second. And you know, unless you really need a deep engrave, probably looking at closer to the 30% power to get a nice frosted look. So I went ahead and did a quick project again, pulled out the old keychain trick again, this time just with the Omtech logo, of course. And got a pretty clean engrave, got a pretty decent cut. It's not getting quite as polished on the edges. So, but it was a clean cut. It was a very clean engrave. I just want to see if we can get just a little more shine on the edge of the cut. As we mentioned earlier, they do talk about this being able to cut up to about 4/10 of an inch or 10 millimeter material. Now this, I found some poplar that I had on hand. Now this is actually about 0.45. It's a little bit thicker than they say. And so I ran some tests on this. I started out with 1 pass and then went up to actually 3 passes, but going 6 millimeters a second, 70% power, 3 passes, we finally did get through this. And it's a fairly clean, it's a little bit of caramelization on there, but a fairly clean cut. So it is possible. I think if you stick to 1/4 inch and lower, you're going to be much happier. And then of course, if you look at this side, these are the cuts I was making. The kerf, because that beam's a little bit wider, I did sink it down into the midpoint, so their focus point was closer to the middle. It just was kind of making a wider line there. And then of course, another popular material is slate, and so I dropped a slate tile in there. Completely guessed at the settings just based on some of my prior experience, but went ahead and did 450 millimeters a second, 30% power, got that framed up, and actually came out very well. This took about 3 minutes, 25 seconds to complete, so not too bad. Not going to be competing with your, your fiber galvo lasers, but for the CO2 and diodes, a lot of times these 3 3/4 or 4 inch tiles, if you're engraving most of them, they're coming in around 4 to 5 minutes on a lot of these. So 3.25, and possibly playing around with this, I might be able to bump that speed up if I can get it into the 500 or 600, and maybe add a little power to get the same levels. You could probably shave some time off that as well, but definitely something that is doable. And with the endpoint sensors in there, so that you can get it home, you can set up a jig, set up a whole group of these, and crank a bunch out in a short time. All right, so that was kind of my initial tests with this laser. It's a lot of the materials and typical jobs that I might do with it. But I want to do more with this. I want to play around with playing with glass, similar to acrylic is something that you can work with. And also see, maybe we can put some of the creature comforts in there that I'd like. Might do a little digging and seeing if I can add in more automatic air, and just kind of make a 3D adapter for that focusing knob. But this is a really nice kind of base platform, getting back into a Ruida DSP controller for CO2. It's not as big as my old one was, and about the only area where I'm gonna miss that is cutting balsa for model airplanes. And even my other one was limiting there. That's where I would love to have the space and the need to have more of like a 36-inch wide cutting bed. But I don't do as much of that right now, so it's not a critical issue. This is a really good size for what I'm doing here, and hopefully something that might work for you in your shop. Not a lot of cons to it. I mean, there are some reasons you might want to look at, say, a benchtop one like the Omtech Polar. You do have to have, build a base, you need to add a chiller and such. Those others are going to have that in it, but they're definitely going to be kind of locked into what accessories they make for it. This one, I can do some playing around with it. I've got that depth. I mean, I can put in a whole ammo can. I can put in a completed gift box kind of thing. It's got some flexibility there. I can upgrade the tube to a higher power one just by extending that box out the side. So I think the reason you might look at this one is you want some flexibility, you want some more space in there, and you want kind of more of those standard, you've got lens options, you've got mirror options. You can kind of use this as a platform and make it your own, whereas a lot of the desktop ones, they're great for people who just want to drop it in. They want to do projects that fit in that laser. So you might want to look at those if that's more you. It's going to be easier to put on a bench, whereas this one you got to build something. But like I say, this one is definitely going to give me some flexibility in how I use it in the future.
Let's take a look at the prices of this laser. So here we are on Omtech's site, and you see the normal price is roughly around $2,400, but they often have sales, and currently this one is on sale for about $1,900. Now, if you use my affiliate link down below, you will actually save 5% off of anything off of Omtech's website, so appreciate you using that. It is an affiliate link, and I will get a little bit of a kickback on that as well, but it also tells them that you appreciated my information, and hopefully I can continue working with them in the future. They do have a few different options, and the ones you might want to look at. The base machine, like I mentioned, right now is $1,900, but if you're new to this and needing to get light burn, they actually will include the full light burn, which now with their changed licensing options, to get it straight from them is about $200 for the one that is the DSP controller version that runs with this Ruida controller. So another $100 on there gets you the option with light burn. They do have an option where you can get light burn and the rotary with that. So if you're looking to doing tumblers with this one, you may want to go ahead and add that on there. get a little extra savings on there. But I would at least recommend the machine with light burn. The other thing that we mentioned earlier is the chiller. They do have their chiller that you can add on. It is about $530 for this one, but that's going to keep your laser running very well. It's going to keep that temperature in that tube at a set level. So strongly recommend this to add to your laser as well. Everything else, you know, kind of optional add-ons down the road, but getting the chiller and at least the laser, maybe light burn if you need it, definitely a good way to go.
So that's where I'm going to leave this video. I hope I gave you a decent overview of the Omtech Maker 25. Again, this is a 50-watt CO2, and it's kind of in their kind of intermediate range of lasers. They do have a full line of lasers, so if you're curious at what else they have, again, check out my links down below. That'll take you to what they've got for fiber lasers, CO2s of all kinds, and benchtop to full large cabinet ones. So I hope to do more with this in the future, and we'll probably be working on some projects, maybe, like I mentioned, some upgrades. So if you're interested in that, consider hit subscribe, and also let me know what you'd like to see. I get a lot of good inspiration from my viewers, and it also helps you out on something that maybe I can test for you, give you a little bit of ballpark to get you going on a project or some material. So hit up that comment section, tell me what you'd like to see, and I'll see what I can do for you. Otherwise, I do a number of things in my workshop with CNC routers, lasers, 3D printers, just general building and making. So if that's something that interests you and you're new here, hey, consider hitting that subscribe button. If you like this video, do me a favor, hit that like button. Throw any comments down there. That definitely does help this channel and help YouTube know. They should let other people know about this video. So appreciate all that support, and hopefully I have given you something good in return. So that's it for today. I will see you again soon, but I hope you can get out into your workshop and make something too. We'll catch you next time.